Okay, this is just a recap of what we did yesterday. Synthetic division one more time. You guys did your homework assignment, and the going consensus from what I asked, people didn't seem to mind it much. We kind of liked it, right? So if I'm doing synthetic division, and I put this little backwards bracket here, what goes in this hole? What kind of 2? Positive 2 goes in that hole, because whatever this is, we have to change the sign of the number. Synthetic division is possible because it's x plus or minus, but whatever that number is, we change its sign. That's how we do synthetic division every time. So positive 2 goes in that hole, and then 3, negative 7, 5, negative 1. Does that function look familiar?
Yes.
What does it look like?
The synthetic.
But does that look familiar?
Oh,
That's the same problem.
Isn't that exactly what we just did? Right? They're the same? Okay, I did that on purpose. You'll see why in a minute. All right, so 3x cubed minus 7x squared plus 5x minus 1 dividing by x minus 2. So 2 goes up in this little bracket here. And the last step of setup is we move that 3 down there, right? So that's the whole setup of synthetic division, what we learned yesterday. All right, and if I perform synthetic division, I'm going to multiply this times this to get the next number up. I'm going to add algebraically these. The signs are different, so I subtract. 7 is bigger than negative to get the next number down. Multiply 2 times negative 1 to get the next number up. Add 5 and negative 2 makes positive 3 going down. Multiply 2 times 3 equals 6 going up. And negative 1 plus 6 equals 5 coming down. So if I perform synthetic division, which is what it's asked me to do, and once I performed it, remember this is the remainder, this is the constant, this is x to the first, this is x to the second. So 3x squared minus 1x plus 3 plus 5 over x minus 2. What I wanted you to see, and the importance of what I just did here, by using the exact same function on both of these problems, I'm going to go side by side real quick. This remainder matches this number here. That is not a coincidence. Okay, now notice what happened here though. If I'm doing f of 2 and I want to know what f of 2 equals, I put 2 right there in that box. I don't do any changing of signs there. If I want to find out what 2 equals, I put 2 in. If I want to divide by x minus 2, I have to change it to positive, I have to change the sign. All right? The remainder theorem states that if you divide any polynomial by x plus a, is what it says, or sorry, x minus a, then the remainder is the same as f of a. So if you divide f of x divided by x minus a, the remainder equals f of a every single time. So x minus 2, a is 2, right? So f of 2 is 5, which is the remainder of the division. The usefulness of that is it's a checking tool for these problems. If I divide by something, right, and then I do f of that number, which is not terribly difficult to do, if my remainder matches, I probably did it right. If I have the right remainder, I'm probably right. Okay. There are ways to get the right remainder and be wrong, but it's not likely. It's highly likely that if you get the right remainder, you probably did the right answer. If you recall yesterday when I had you do the long division by yourself, I asked who got a remainder of 52. That let me know that if you had the remainder of 52, you were probably right. If you didn't, you were definitely wrong. All right? So if you have the wrong remainder, you're wrong. But if you have the right remainder, you're probably right. 99.9% of the time, you're probably right. So, in general, if you want to do this, you can do it that way, get a remainder, or you can do it this way. Both ways work every time. All right? So if you want to evaluate f of anything, just stick that anything in the box. Perform synthetic division, and you get the right answer. Always works.